Alright people, let's do some vectors. Can't really do vectors. It's not really the right way to say that, but you know what I mean. We're going to do some problems about vectors. This is them, so let's get busy. Number 11. Oh yeah, and I've got my my vector notes, I've got them handy right here, just in case I need to refer to them. Maybe a good idea, right? Have your vector stuff close by to you. Number 11. In unit vector notation, what's the sum of A plus B if A is 4? I drop the units when I'm actually getting into the math, like same as what I'm doing when you get sort of into algebra mode in physics. I like to drop the units. I think maybe some physics teachers out there in the world would be horrified by that, but what are you going to do? Can't make everybody happy. What we want the magnitude and direction of these. Okay, so I'm going to do it in component form first. 4 minus 13 and 10J. All right, so for part A, we're going to find the direction. Magnitude. Oh, I guess that was part A. Sorry. That's in unit vector notation. That's part A. So part B, they want the magnitude. That's part A, which is going to be the Pythagorized that, which is my handy calculator, which still is telling me I need to change the batteries. .5, and my units are meters. That's the risk, I guess, of dropping your units, is forgetting to put them back on. And then I'm going to do tangent inverse, rise over run. I'm going to ignore the negative sign. And that gives me 48 degrees. And where am I here? I am negative positive. So that's quadrant 2. Do my fancy Roman numeral there. So if you had to draw that out, it's 48 degrees into quadrant 2. Always we're talking about going in from the nearest x-axis. We're never doing that. All right. I suppose I should check the answer for that, just to make sure I didn't mess something up. Give you some bad info. I don't think I mess up problems like this. So they pay me the big bucks. They called that 132 degrees, like from there, so 48 degrees into quadrant 2, that's the same thing. So, all good. All right, number 13. A person desires to reach a point. Why, I wonder? Why do they have this desire? A person desires to reach a point that is 3.4 kilometers from her present location and in a direction 35 degrees north of east. All right, I'm going to make a little sketch here. 35 degrees, so if this is east, north of east, that's just into the first quadrant. 35 degrees. And I want to go 3.4 kilometers in that direction. That's where this desirable point is. However, she must travel along streets that are oriented either north, south, or east, west. What's the minimum distance she could travel to reach her destination? So that's just asking for the components of this. So what is it? What's my angle? 30 degrees? 35 degrees. So she would need to go in the x direction. She would have to go 3.4 cosine 35. And then in the y direction, she would have to go 3.4 sine 35. And if we add those up, that's the distance she has to go first east and then north. Or I suppose you could go north and then east. if the roads are there to do that. So 3.4 cosine 35 is about 2.8. I'm sticking with the same number of sig figs that they gave there, kilometers. And 3.4 sine 35 is 2.0 kilometers. So that looks like she's got to go 4.8 kilometers. I'm just going to go with that that's right, and we'll check it in a minute when we check something else. 15, two vectors A and B have equal magnitudes of 10, and the angles are 30 degrees and 105 degrees. And they have a little picture of that. They want what's the x and y components of their vector sum, and the magnitude and the angle that it makes with the positive direction of the x-axis. All right, so just have to add these up, is what they're saying. So I would like to have these in component form. So vector A is going to be, that's just 30 degrees, so I have 10 cosine 30, 8.7i, and I know what the sine of 30 degrees is, but you do too, so I don't need to use my calculator for that. So that's the vector A. Vector B is at 105 degrees. If you have the angle that's measured from here, like in the whole 0 to 360 range, you can do cosine and sine with that angle, and it'll pop out the correct SIGN. It'll pop out the correct sine for you. If you make that adjustment and say, oh, 105 degrees is the same as 75 degrees into this quadrant, and you use the 75, and then you just say, okay, the x has to be negative and the y has to be positive. Either one of those is okay. You just have to make sure that if you're using these reference angles, like the ones that are always between 0 and 90, that you pay attention to what your sines need to be depending on what quadrant you're in. All right, so I'm going to do it that way. So let's see, I got 10 times the cosine of 75 is 2.6, but I know that I'm in the second quadrant, so that's negative. And 10 sine 75 is going to be 9.7. All right, now, what do we need to do with those? I need, for parts A and B, what are the x and y components? So if I add these up, that's going to be 6.1i. That's the answer for part A. And then here I've got 14.7j. That's that answer there. And this is meters. All right. And then for parts C and D, I want the magnitude and direction. So the magnitude, I need to Pythagorize those. That's what I'm doing quietly here, Pythagorizing. You can Pythagorize very quietly. It turns out it's not a very noisy activity. Don't forget your units there, and the direction, tangent, inverse, rise, overrun. And then here, it looks like we have positive both of these, so I'm in the first quadrant. So that's 67 degrees, rounded to the nearest degree, 67.5 perhaps. Let's see, let's check those last two answers, make sure that we are good. Number 13, yeah, they have 4.74 kilometers, that's fine. And then 15, I got 1.5. No, what? Uh-oh, what did I do? 15, 1.59 and 12.1. Oh boy, my answers are all wrong here. Let's see, what did I do? Oh, I see what I did. I did not, I didn't look at the picture. So I made this 105 degrees, but that is not what's going on in that picture. So we need to do a little geometry and then fix this up real quick. Let's see. So the first one here, theta 1, this is 30 degrees. So these are good. But then the other one, it's like a turn of 105 degrees from here. So this is 105 degrees. All right, so we have to do a little bit of mathematics here to figure out. What I would like to know is what's this angle, right? So, you took geometry, right? That's a good class. Hope you had a good experience there. So these are alternate interior angles. So that's 30, that's 30. This is also 30. Those are called vertical angles. You know, geometry is the one math class that I've never taught. I pretty much have taught. I taught Algebra 1, I've taught Algebra 2, taught pre-calculus, calculus obviously, did some another advanced topics in mathematics. That was a lot of fun. I basically made that course up. Let's see, does that add up? No, that doesn't add up. That's just 45, I think. So 45, 30, and 105, because that has to be 180. I like geometry. It's not like I, ever said, I'm not teaching geometry ever, because I hate it. Just never happened. Okay, so we got to fix these. Maybe I should just give you like little bits of my life story as we go through all this pandemic learning. So this is going to be, they're both going to be negative 7.1 because it's a 45-degree angle. So that's going to speed up our fixing of this. All right, so that is 1.6, it looks like. And this is a 12.1. Sorry, that is totally possible to read. 12.1J. And then this let's see, 1.6 squared plus 12.1 squared, that's 12.2 meters, and then tangent inverse rise over run, 82 degrees. All right, let's check again and see how we did. Let's see, this is number 15. Yep, there we go. All good. Sorry about the confusion there. Pay attention to the pictures in the book. All right, two more. I don't know if it would, how that makes you feel when you are watching a video and your physics teacher makes a mistake like that. If it shakes your confidence in your physics teacher, or if it makes you feel like, oh, everybody can make mistakes. He's just human. I hope it's the latter. I do know how to do this stuff, promise. But just like you guys, make mistakes sometimes. 3 vectors A, B, and C each have a magnitude of 50 meters and lie in an xy plane. Their directions relative to the positive direction of the x-axis are 30, 195, and 315. I'm going to draw a picture of this. So they have the same magnitude. One of them's at 30. This one's the one that is called A. The next one is at 195, which is 15 degrees past 180. That's the one that goes by the name of B. And C is at 315, which is 45 degrees short of 360. So notice that I'm always looking for the nearest x-axis to find that reference angle. Okay? That's the one that's called C. We want to know what's the magnitude and angle of ABC, A plus B plus C rather, and then magnitude and angle of A minus B plus C, magnitude and angle of a fourth vector D such that A plus B minus C plus D equals 0. Okay, so this is just a bunch of algebra, basically, at this point. So for part A, not to be confused with vector A, we want to do A plus B plus C, and I think parts A and B are the magnitude and direction of that. So let's find the magnitude and direction of all three, and I guess we can use these for all the parts. So A, B, and C. A is going to be, they all have a magnitude of 50, right? All right, so this first one, A, I got 50 cosine 30. How many sig figs do they give on that magnitude 50? Just one. So I'll run this to 43. I. And these are both going to be positive for vector A because I'm in the first quadrant. And then it's going to be 25. Okay, for a vector B, I'm going to do 50 cosine 15 and 50 sine 15. And I'm going to make sure that they're both negative because I'm in the third quadrant. So let's see, 50 cosine 15 is about 48, and 50 sine 15 is about 13. And then vector C, I got positive, negative. Put a positive on that too, just to make doubly sure that we're paying attention to direction. This is 45 degrees, so whatever I get here for 50 cosine 45, that's going to be the same for both. 35I, 35J. So A plus B plus C, that's just adding these up as is. Probably could do that in our heads, but here's the calculator right here. So that's 30I when I add those up. And then 25 minus 13 minus 35. So that's A plus B plus C is that. And was it meters again, I believe? Yep. So the magnitude and direction of this, Pythagorize those. I sure do hope that you're not wasting your time, which is very precious, I think, these days, watching these videos if you got the problems right. Certainly, if you're waiting for somebody to give you permission to not watch these videos, the solution videos that is, then I'm giving you permission right now. Alright, now it's 37 degrees where, let's see, this is positive, negative, so that's the fourth quadrant, so that's like 37 degrees, like down here. If you wanted to be consistent with the way the book presented those angles, then they're doing it like on a 0 to 360, so it'd be really like 360 minus this. So you could say, I'm cool with you saying that it's 37 degrees into quadrant 4, but the book is probably going to say that it's 323 degrees, and we'll check that in a minute. Alright, so that's, I guess, the answers for A and B. For C and D, we want A minus B plus C. So depending on how good you are at keeping track of things and the management of signs, I know that that's just going to be this, this, and this, but with the sign of this flipped. If I'm subtracting B, then that subtraction would distribute through these and make both these positive. So that's going to be 43 plus 48 minus, plus 35, plus, plus. That's still plus. So 43 plus 48 plus 35. If you feel like you need to rewrite this for management purposes, of course you can do that. So 25, I think this is going to be 3j, right? This plus this is 3. Yep, looks right. So the magnitude, if I Pythagorize these, this is, I don't know how much of an intuition you have for this, but it's going to be 126, right? That tiny little 3 there, it's not going to change the length of that. This is like a really super skinny triangle that's got one really, really long leg and then a tiny little, so that's also going to be 126. I'll just show you. If you Pythagorize 126 squared plus 3 squared, it's 126.04. So, and D, that's going to be really close to 0, right? 126 and then up 3. That's got to be like not more than 1 or 2 degrees. Let's see. Tangent inverse of the rise, 3 over 126. So rounded to the nearest degree, which is what I'm doing here, that's a 1 degree, and that is in quadrant 1, so that should agree with how the book reports it. And then last, they want to know the angle of a fourth vector d such that a plus b minus c plus d is equal to 0. That's the same as a plus b minus c is equal to minus, let's see, minus d. Well, let me not skip this step. Forget about that symbol there. That's just scribbled out. So distributing the minus sign from what they're asking us to do, right? Minus signs still distribute. And that's what I want. So a plus b minus c, if I add this to the other side, the vector that I'm looking for, d, is just this, right? It's equal to a plus b. If you want that to be true, that equation that they gave, this is what you need to do. Okay, so a plus this one minus this one. So can we manage that? Let's see. So vector d would have to be this plus this. That means not changing the sign. So 43 minus 48. This is the one we changed the sign of now. Minus 35. And then this and this just as is. And then this one we're changing the sign. And then for the answers for E and F, we want the magnitude and direction of this, right? Yep. Okay, so I need to Pythagorize those. 40 squared. I'm never keeping the negative sign when I'm Pythagorizing, right? Here's a rookie mistake. If you do this, wrong. The calculator thinks that what you mean here is that you want the negative of 40 squared. It doesn't think that this means negative 40 squared. So if you put it in like this, you are going to get the wrong answer. And that is a rookie mistake. So the pro move here is to just ditch the negative sign. Don't put the negative sign. You don't need to go in and do this, because, you know, we're all grown-ups here, nearly. I don't know. Do you think of yourself as being an adult, a young adult, I guess? That's why I like teaching high school seniors. If you have to pick a high school level to teach, because you guys are pretty much like fully developed humans. Whereas like when you get into the age range of like 12 to 14, 15, there's a lot of like weird stuff going on. So don't really need to mess with that. Let's see. Angle of fourth vector. People who choose to teach middle school, oh my goodness, what is wrong with those people? Tangent inverse rise over run. I say all these things very tongue-in-cheek, of course, you know. About 50 degrees if we're rounding to the nearest one. And where are we? We are negative, positive. That's the second quadrant. So the book is going to report that as 130 degrees, right? It's 50 degrees shy of 180. All right, let's check those to make sure I didn't make any more mistakes. That's number 17. So we got 38 meters is good. Negative, oh, they called it negative 38 degrees. So that's another way to do that. Of course, going negative brings you to the same place, so that's all good. And C, 130, they called it, and 1.2 degrees. So what they said that it's 130 because they were keeping one less sig fig than us. So that's fine. That's never going to be a problem for you on any kind of assessment. And then 62 meters and 130 degrees. So all good. All right. Last one. In a game of lawn chess where pieces are moved between the centers of squares that are 1 meter per edge, a knight is moved in the following way: 2 squares forward, 1 square right, and then some other different legal moves for knights. Okay, and then they want the whole thing for the 3 moves. So what are we doing here? The first move is 2 squares forward and 1 square over. And then 2 squares left. That brings us back to here, and then here, and 1 square forward. So now we're here. So it's like go to here if we wanted to make our little vectors here. And 2 squares forward, 1 square left. 2 squares forward, 1 square left. Into there. And they want to know the overall magnitude and angle relative to forward of the knight's overall displacement for the series of 3 moves. Okay, so what's our net? It looks like if we did this like on a little piece of graph paper, then it looks like to get here we have a net of 2 in the I direction, right? See where I'm at there if you did it on graph paper. Make my little grid a little bit more obvious. So 2 over this way, and I think we end up 5 forward. 1, 2, 3, 4, 5. So plus 5j. And this is meters, because that's what the scale is of this. And magnitude would then be .4 meters. I think that's the answer for part A. And then the angle, I'm going to ignore what they said about how to report the angle just for a minute and find it like I always do. So tangent inverse rise over run is 68 degrees. Since it's negative positive, that's in quadrant 2, which we can clearly see from our picture here. Now they asked for what is the direction relative to forward. So they actually want, if this is where we end up, if that's sort of like our end position vector here, They want this angle here. So if this is 68, then this is 22. And that would be like to the left of forward. If you said here that, oh, I said that it was west of north, and that's the same thing, right, Mr. McGrath? No, it's not the same thing, because there's no reference in this question about what north, south, east, and west are. We don't know how this game, this lawn chessboard is laid out. We have no reason to believe that this is north. So I think that sometimes maybe when you do some of this angle stuff in pre-calculus, you get this false sense of the positive y-axis is always north. That's not true. If it's given in the problem that it's like a north, south, east, west problem and it's laid out in that way, then you can say that, of course. But here, all we can say is that it's left of forward. And I don't know what direction forward is pointing in. Who knows? And let's just check those real quick. And 19 looks good. They kept one more sig fig than I did, but that's all. Just fine. See you later.